And now, welcome to this video. We're going to look at a bandwidth management tool called Cake. It's not as interesting. Well, it is interesting. It's not as delicious as it sounds. It stands for Common Application Kept Enhanced. This is moving on from a video I did about PCQs for fair bandwidth management. Making the user experience more enjoyable. But this is maybe a step further. It's now available on router OS version 7, whereas before it wasn't. You'd have to sideload open WRT or something like that. But now it's all built in, which is really handy. But basically, in simple terms, it controls and prioritizes the traffic. So in a busy road, if you like, the more sensitive of types of traffic, such as voice and video, those sort of UDP streams, won't get stuck, if you like, with the large amounts of, say, downloads or video, large files, which could then, buffer, jitter, cause all sorts of interference. Hopefully that makes sense. So it reduces the delays, so the latency, and makes the online experience less laggy, for want of a better term. So there's a term which is used called bufferbloat, which is the excessive latency caused by overfilled buffers in the network equipment. So when a network device receives device receives data faster than it can forward it, it temporarily stores that in a buffer. So buffering is necessary. That excessive buffering causes delays and poor performance. So for the more time-sensitive applications like gaming or voice over IP, VoIP, video conferencing, that sort of thing. So some key features within Cake is the bandwidth shaping, which enforces bandwidth to limit and prevent congestion. The per host fairness, so allocating bandwidth fairly among individual users and devices. The ACK, so the ACK, the acknowledgement filtering, so optimizes TCP traffic by reducing any redundant acknowledgement packets. And the simplified configuration, so it's very easy to use, very easy to set up, and it's so far, from what I can work out, very robust. So let's get into the configuration. As I do with most of my videos, I have a link in the description to my website, which will have a sort of a step-by-step guide, which will go through the configuration here, and we'll talk about some testing at the end. So I'm hoping what I'm going to be able to do is replicate this buffer bloat. I'm going to generate lots of traffic on the network. Here's a rough topology of what I've got set up. So we are on this test device here. My test router is the one that this device is connecting to and routing through. And then that is onward traffic is going to my development router, which goes off the internet. And hanging off my development router, I've also got a Linux server, which I'm going to be running as my iPerf server. So those that are not familiar, iPerf is a way of bandwidth testing. So what I'm going to do is simulate a download. So I'm going to be downloading traffic from my iPerf server through this router, and this is the router that we're going to set up with our Cake bandwidth management. And then we'll also download some large files. And then I've got this website which I found, which is internet speed testing for bufferbloat. I keep saying bufferbloat, not boat. And then the way that works, I'll go into more detail when we do it, but basically it will do a speed test. It will test the latency, any lag, if you like, on that line, and then it will run that test. And then if that lag increases, then it will determine that there is this bufferbloat. There we go. Right, so let's get set up. So this is the router that I'm on. This when I'm routing through, it's actually a CHR. So the machine that I'm on is also a virtual environment on VMware, same as this router and same as the onboard router, the development router. But this could be any MikroTik, any router you like. So to match my traffic, I'll show you I've got two networks. Sorry, no, I've got one network. This is the one I'm on user. And I'm going to be routing out of this Ethernet 1 interface. So we want to match all the traffic on this one. Just see, I'll see the IP address I'm on. So there's that one, I'm on there now. Okay. So let's go. To do that, if you have seen my PCQ one, it's exactly the same way. We're going to use Mangle rules because I'm going to build when I build the cake queue type, I'm going to apply it in a queue tree as opposed to a simple queue. Again, we'll go through that. So here I have my address list, user 1, there's my subnet there. So we go to Mangle rules. Then we need to add 2, we need to add upload and download. So my upload is going to be pre-routing, and my download is going to be post-routing. My source address list, because we're matching on the source, because it's upload, and then my destination, because it's download. The destination will be my subnet there. Okay, that action, all we're going to do is mark the packet on both, untick pass-through, because again we want it to stop once it actually makes the match, and not pass it through any other rules. And we will call this user 01. This one's upload. And this is user 01-download. Okay, pretty straightforward. There we go. It's already matching stuff because I'm writing through that now. So that's my Mangle rule setup. Now we can do the queuing. So let's go to queues, queue types first of all, and then we're going to add one, and we're going to select cake, and we'll just call this cake for simplicity. So there are lots of different ways you can configure this, but the way I'm going to approach it is from say like a home or a small business, and the key things we're going to focus on is this overhead here. So if we jump back on the website, I've got a table down here which kind of has the overhead is the bytes of the overhead of the packet. So we're using the Ethernet, so we're going to add 18, but we could be using PPPoE or a VLAN, because then that adds the extra onto that packet to compensate. And then DSL, we sent somewhere between 8 and 40 is quite a large range. So yeah, we're going to go for 18. Again, a bandwidth limit here, we're not going to set it in here. We're going to set that in the actual tree itself when we build that. So you can leave that one blank. The other thing we're going to set is, we're actually going to leave it as it's already set. This is diffserve 3. Now this is, so best effort basically treats all types of traffic the same. So we've got 3, 4, and 8. And again, if we head over to here, we've got these, basically the way it prioritizes the traffic. So the 3 is a fairly sort of a one step up from best effort. So it's basically bulk, best effort, and then voice. So it's basically going to prioritize voice over everything else. If we went the next one up, we would have then video and voice. So that's more if you've got a corporate environment where lots of, Teams, WebEx, Zoom calls are happening, as well as phone calls, and then all the other traffic. So at the end, it's prioritized as this set as 1, and then best effort. And then we also have that divserve 8 available as well, which is even more detailed. But again, if you check out the MikroTik's website, you'll go into a lot more detail for this, but I've just tried to keep it fairly, useful information, what I think is useful information. So, and then the other thing I'm going to do is this acknowledge filter, which I mentioned before, which it reduces those unnecessary acknowledgement packets. So hopefully speed the TCP traffic up. If you're familiar with the way TCP works and handshakes and such. And then to turn that on, we just select filter. We have this aggressive option, which is basically this on steroids. But again, for what we want, probably I would suggest filter is always the best way forward. Okay, so we will okay that. Now let's build our tree. So I'm going to build 2 lots of upload and download just for the demo, which hopefully they'll be able to replicate. So There we go, download, and we'll call that default. And this is going to be upload and default. Packet marks. This is where we use our Mangle rules. So we want download. We want upload. The upload is not really going to use because at the moment we're just going to test download in this example, but you know, still good to have. And then we're just going to use default small as the queue type in this one, and then we're going to give it a 25 meg. 25 meg. Okay. Another option we could do, which is available on all queues, is this burst. So we could add like a 50 meg burst rate if we had that bandwidth available, and for a period of time. So if you're aware, when you load up a video stream on Netflix or YouTube or something like that, you get a large amount of data and then it's buffered. So you kind of, if you ever watch the bandwidth, you watch a graph or anything, you'll see it sort of spikes and goes down and spike up and down, up and down. So it just gives you that first initial. There's also for like if you're loading a web page, nowadays there, lots of content on there, and it needs to load lots of graphics and stuff like that very quickly. But once it's loaded, you can then, there's minimal bandwidth then between the two. But again, we'll leave that out for this example. So we'll copy that. Now what I'll do is I will just open these up, and then I will just copy them. Okay, so new queue and new queue, we'll get rid of these ones. And now these ones we're going to call download dash cake, upload dash cake. Okay, and now this time queue type, we're going to select our cake and cake. Cool, and then we can leave the rest as it is. So at the moment we're going to be using the cake ones are going to come first because it's put those in that order because they're alphabetically in order. But what we'll do is we'll just go ahead and select both of those and disable those. Okay, so download, all good. Right, let's do some testing. So, as I mentioned, I've got an iPerf server running on this address. This is routing through my router and then onto the development network. Basically, we're going to connect. This is the client, sorry. Going to connect to that IP address. I'm going to run it for 60 seconds. Sorry, 600 seconds. And then we're going to try and download 100 meg in reverse. So the reverse, so that if I didn't have the -R, sorry, that would be sending. But we're going to do it in reverse, so we'll run that now. Okay, it's running. Okay, and okay, so I actually should have meant to select queue type default, sorry, not default small, which we're now. There we are. So I'll just stop and start that again so you can see. Okay, there we go. So now we're downloading and it's limiting it. So we're still downloading that 100 meg there, but we're going to get in 25 there. So again, if I just stop that one, you should see it goes back up to, well, there we are. It's going up to nearly 300. There we go. So let's set them back to 100 because that's what we should be downloading. Okay, and then we enable that again. Right. Okay, that makes sense. Right, there we go. So just to show you, if I was to get rid of that R, just to show you the upload queue, we're now sending 25 megs worth. And there you go. See, it's gone red. Okay. Good. Right, let's get that running. Now what we're going to do is let's download, as I did on my PCQ video, download Ubuntu because it's a sort of 5 gig file. There we are. So I reckon it's going to take me 2 hours. Let's look at my queue. Okay, nicely maxing out, and this is now dropped, so it can't get to my 25. We're getting about 2 and 3. Okay, now what we're going to do is we're going to run this speed test here and see what it does. So let's start that test. So as I mentioned, so first it tests the latency of the internet, which is this one here, and then we compare the results to a latency test performance while running speed tests. So if the latency increases while we're upload and download tests are happening, your router network equipment suffers from bufferbloat. Okay, so now it's just starting that download. And once that gets going, so it's going to steal all the bandwidth pretty much. So that download is probably going to go quite slow. Yeah, jumped up to 4 hours now. What's this doing? Oh yeah, barely anything. It's gone back to, it's going to gone down to kilobytes. As you can see now, the active latency is going up quite high. So upload probably won't be too badly affected. Right, maybe it is. Okay. Just wait for this to finish. B. So the latency increased moderately under load. That basically means we'd struggle with 4K low gaming, streaming. Okay. So let's tell you what we'll do. We'll turn off our. Actually, no, if we turn off our queues, it's just going to give us more bandwidth. So it's not an ideal representation. Okay, now what we're going to do is we will stop this so it doesn't time out halfway through. Let's turn off these ones. Then let's enable our cake. Make sure it grabs, it limits our bandwidth. Cool, which it's doing. That is sort itself. I'll still that download running, hasn't I? Yep. Okay. Well, let's see. You can see that's already down to an hour with this running as well. So it's hopefully assigning the bandwidth a bit more fairly. And now we run this again and see what happens. I might just fast forward this bit and we'll get to the results at the end. Okay, there we go. So I don't know why it got stuck halfway through, so I refreshed that page and then just run it again. But yeah, didn't increase either upload or download during that, and it only started off with 6 milliseconds of latency. Claims to have done more than it was 25 on what we set it to, so that's fine. It's within that limit. A+. So the only thing it's moaning about, or not moaning, but saying we might struggle with is 4K streaming. But I think that's more to do with the bandwidth. So I think if we perhaps tested with more, we might get a better result on that. So yeah, hopefully that's somewhat useful. Again, it's often in these sort of environments it's hard to test sort of real world examples, but showing that's enough to show that we put a bit of load through it on a normal queue. We like I did with the PCQ ones, I had 2 different PCs, one with and one without. I applied the different queue types and then the reran. So I basically was downloading the Ubuntu file and then I reran the speed tests. And because the speed test and download were operating on different ports, that's how PCQ per port connection queues work. It was allowing basically more bandwidth through and giving a better experience, whereas we're still limiting each user to that 25 meg. However, we are hopefully supplying all the smarts to give it a better experience for the user. So it's dividing that bandwidth up and prioritizing stuff more efficiently. So, but yeah, please, this video was came from a suggestion off the back of that PCQ one. So if you do have any other ideas or suggestions for videos, or if there's anything you've tried or you've tried one of my videos and something didn't quite work, please comment below. I aim to get back to everyone, and where possible I've so far managed to make all of the suggestions that were asked of me. So yeah, if not, I'll just say thanks for watching. Please like and subscribe. Means a lot when people do, and if not, check out their website in the description below to take you to lots of other tutorials and stuff like that. But if not, I'll see you on the next video. So thanks.